So the first one, like batch, if you guys are familiar with the term batch, that means just like bringing a bunch of data in at once, right? And that's the traditional way that OLAP or analytics databases worked. And we still support that. So actually, traditionally you would bring it in all overnight. You don't need to do that with StarRocks. You can bring it in as much as you want, but you can actually broker or batch it in from S3 or HDFS. So this is a really common way to just bring data into disk in StarRocks. You're actually copying it over from that data source, which is S3 or HDFS, and you're bringing it into StarRocks in a batch. But we can also do this, and I'll be, yep, do you have a question? Sorry.
No, go ahead.
Okay. So make sure. So the second way is what I'm also going to show in the demo, and this is if we actually query on the data lake. So the data isn't brought into StarRocks. Maybe you need your data for whatever reason to stay in your data lake. You're not supposed to copy it over to a different system, or you don't want to. And maybe you want some query performance improvement upon like what you're already getting if you have like a pretty basic query engine on top, but you don't need necessarily the super fast that you would get with a disk. So this is the option you have to do an external table. So we call it like lakehouse analytics. So you can have that data actually live in a data lake and be queried by StarRocks. We can still offer like optimizations to make it faster. So we can do like a materialized view, and most people will use a kind of a combination of both internal and external. So you're not bound to one system. If you use StarRocks, you can use a bunch of different ones. The last one is the real-time analytics. So this is, again, if you're streaming data in. So another problem with a data lake, or a challenge with a data lake, is, right, if you wanted to stream data, you want to get data really fresh, it might be kind of hard if you wanted that to come. So say you have an IoT device or something. You're streaming data in from this weather sensor, whatever, and it's coming into the cloud. If you want to persist that to a data lake and then like read that data from the query engine, that would be added latency, right? Because now you have to put it in the data lake. That's going to have IO time. And then you're going to take it out of the data lake to be analyzed. That's added IO time. So what a lot of people will do is they'll stream their data directly into StarRocks, as well as maybe keeping a copy on the data lake. But this would allow you to, StarRocks can actually be a Kafka sync. So it can connect directly into Kafka, which is a popular streaming tool, and take that data and it can read it. That's how we're able to do that really, really fresh data. So when we say real time, we don't just mean like fast query speeds. We also mean freshness. That's really where, like when we talk about real time, we're talking about freshness. You're able to get that data that's from 5 seconds ago, So you're no longer stuck in reports that are recent only until yesterday. They're recent until 5 seconds ago, which is really our bread and butter and what we're able to do really well.
Okay, pretty cool. One question from my end, and this could be a very naive question that I wanted to ask was around, how does it differ from other data storage and analysis solutions? Like, how do you look at it? Like, and this is the most basic question, but we have a lot of questions that I would want to take from our audience. But what do you think about this?
Yeah, so I think so. So when your data's on a data lake and you're finding a way to query it, there's a lot of different options, right? It's not just StarRocks. There's tons of different ways that you can query data. It really depends on your use case, right? So for StarRocks, we do big data. We were designed for big data, for high concurrency. So you're going to really see that performance improvement if you have like a lot of data, right? If you have a small amount of data, you might not need something like StarRocks to do the query engine. And then the other thing we do, and I think I have this on a slide, but I'll just talk through it, is so some other query engines, they will require you to do this process called denormalization. Fancy word, but basically what it means is, so typically we have, if you think of structured data, you have like a star schema, right? Like a fact table and dimension tables or lookup tables, and they're all connected through keys. In some other data system or query systems, they require you to stitch all that together. So you have to actually make this big, they call it a flat table. You have to make this big table where you actually have all those tables stitched together. This process is called denormalization. And what happens when you have really big data is that that's a really expensive, difficult process, because that's a lot of data to process. Like you might have to use a tool like Spark or something like where you have to actually maintain and pay for that tool just to stitch that data together. StarRocks doesn't require that. So that's a key differentiator. You're able to actually query your data as it comes in, like as a table. And so just a recommendation for if people are getting started with data analytics or data lake analytics, or just like their analytics and stack in general, when you're working with a vendor or when you're looking at different software to use for a query engine,
Mhm.
ask if you have to do that denormalization process and try to find a way and see if that makes sense for you, right? Because if you have a small amount of data, that might not be a big deal. But if you have a lot of data, you need to add that into your total cost because you're going to have to do that processing in advance. So we don't
Yep.
require that. So that's why we are able to save a lot of cost in your entire architecture because you don't have to do that.